5A, and I believe there are only 2 problems. Correct? All right. Number 1. On a certain exam, the average of all the scores was 50 and the SD was 10. So I'm going to draw that normal curve. So here is 50, and then it's really easy to know where to put plus 10 because I go to this inflection point, which is right there, where I transition from concave down to concave up, and that will be 60. And then this will be 40, and then that same distance I put over here, 30, and then this distance I duplicate up to 70, like that. So A, convert each of the following scores to standard units. And to convert to standard units, which we're going to call a z-score, I take value minus average and divide it by the SD. And it's always value minus average. Why do I do it in that order? So the left ones are negative and the right ones are positive. So in this case, my value is 60. 60 minus my average, which is 50, and divide that by 10. 60 minus 50 is 10, divided by 10 is 1. What does that tell us about 60? It's 1 SD larger than the average. Okay, now, just as a side note, how many people are 60 inches or shorter? Ooh, it's not 68. So I know that this area right here is 68. So 100 minus 68 is 32, but that 32 is split among 2 halves. So each one of these halves is 16. So how many people are 60 inches or shorter? 68 plus 16 will give us this group there, which is 84. Okay? Now, if you can do that, that's chapter 5, pretty much. Okay? Now, we might be going forwards or backwards or in a lot of different directions, but that is chapter 5. Okay. So now 45. 45 is right here. 45 minus 50 is negative 5, divided by 10 is negative 0.5. And we're going to use the decimal instead of the fraction. So negative 0.5, which means that person is half an SD less than average. Okay, and 75. 75 minus 50 is 25, divided by 10 is 2.5. So this person's score was 2.5 SDs larger than the average. Yes, negative is to the left, is smaller, and positive is bigger. Okay, now we're going to go backwards. Find the scores which in standard units are 0. That one's easy, it's 50. Right? If your z-score is 0, you are the average, which is 50, and plus 1.5. How do I convert a z-score back into a test score? Well, I have to take 1.5 SDs and turn it back into points. How do you do that? You multiply it by the SD. I don't know how you did it, but it must have been harder than this. So that equals 15. What does 15 tell us? Not inches, these are scores on a test. 15 more points than the average, so to find the score, I need to add the average back on, and 65. I understood what you meant by inches, but this isn't actually inches. Now the formula there is z-score times SD plus average. But wait a minute, if I'm adding the average, do I have to worry about left side and right side? No, because the average is always positive, and the z will include a negative if we need to go left. Right? The sign on z will tell us which direction we need to go. And negative 2.8. Negative 2.8 times 10 is negative 28. Add the 50 to that, and I get negative, not negative, positive 22. How likely is a score of 22? It's pretty small, right? There aren't many people that far away from the average. Okay, number 2. All right, so we have the list 13, 9, 11, 7, and 10. Now we need to calculate the average. So we add those together. 13 and 7 make 20, 30, 40, 50. 50 divided by 5 is 10. Oh, how nice. Okay, now, this will be the last time I ask you how to calculate the SD. How do we calculate the SD? First, we have to figure out how far is each number from 10. And do we care if it's to the right or to the left? No, because we're going to square it and get rid of the negatives. So I'm just going to ignore negatives altogether. So I'm going to create a new list. How far is 13 from the average? 3 and then 1. And it's actually negative 1, but we don't care because we're going to square it. 1, 3, and 0. What do I do with those numbers? Square them. So 9 plus 1 plus 1 plus 9 is 20. Now I take the average, divide that by 5, and I get 4. Square root the 4, and I get 2. What does that number tell us? On average, the numbers in the list are 2 units away from 10. And actually, they're a little bit closer than 2, but we use the SD and we say that's good enough because it makes everything that follows more accurate. Yeah, the 13 and the 7 had the same effect. Yeah, so if this would have been 11 and that would have been 9, then the SD would have dropped quite a bit. Yeah. Okay, would you say that the numbers in this list are pretty spread out? Not really. Okay, if this was a score on a quiz, everybody scored between 7 and 13. And a bunch of people were right close to 10. Right? 3 of them were within 1. Okay, so we want to turn each of these numbers into z-scores. Okay, now 13. So let's get rid of this. And all we need is that 2. What is the z-score for 13? So it'll be 13 minus 10 is 3, divided by 2 is 1.5, plus 1.5. What does that mean? We are 1.5 SDs larger than the average. Okay? All right, and 9. 9 minus 10 is negative 1, divided by 2 is negative 0.5. What does that number mean? You're 1/2 SDs lower than the average. So what is 11 going to be? Plus 0.5. What is 7 going to be? Negative 1.5. And 10 is going to give me a z-score of 0. Okay? Oh, So now we have this list. We have 1.5, negative 0.5, 0.5, negative 1.5, and 0. What is the SD of this list? Well, turn on your calculators. We're not going to do it by hand anymore. Oops, so clear this out. And I get 1.5, negative 0.5, 0.5, negative 1.5, and the last one was 0, right? Do I need to put the 0? Yes, because it involves the spread, right? If I remove the 0, what's going to happen to the SD? Which direction? If I take away 0, that makes it appear more spread out, so the SD is going to go up. So I need to put the 0 in there. Okay, and then let's do one variable stats. And my new SD is 1. So my new SD is 1. Do you find that surprising? Why is the new SD 1? Ooh, what a great question. Why is this SD 1? Well, let's do it this way. 10. And then if I want to capture 68%, how far to the right do I go? Nope, not if it's 10. What was the SD of the original list? 2. So this is plus 2 and this is minus 2. Okay. When I convert it to standard units, 0, how far do I have to go to capture 68%? 1. So what is the SD of the standard normal curve? It's 1 every single time. And that's why we use it. Because you can take any number with a crazy build-up and an SD, convert it to standard normal curve, and the SD will always be 1 every single time. All right, we're done.